Hello, I hope you all have had a great weekend. We are starting our next essential learning for the school closure, and that is factoring. So we've learned how to multiply polynomials together and find their products. Now we're going to go in reverse, so that's factoring. And we're going to start by talking about the difference of squares. So just to remind ourselves, squares are numbers that when they are multiplied by themselves, so 4 is the square of 2, for example, right? 2 squared. So it'd be if we had a little box, side of 2, the area is 4. I know we all know this. I'm just reminding us, clearing out those cobwebs, right? So if we take the square root of 4, we know that that would be the square root, which is 2 times 2. 2 can escape if we think back to my interesting little prison analogy from way, way back in February. So the square root of 4 is 2. So we're going to do a couple more of these, again, to just think about all the rules we know for exponents already. I'm going to skip down here to x squared next. So we know x squared is really x times x. Another way of writing this could be that you have x squared, and if we use our rational exponent rules, this square root turns into a 1/2 exponent. And we know that we multiply for a power of a power. Well, 2 times a half is really 1, so this turns into just x. And you put that in integer number 1 exponent if you wanted to. It's a different way of thinking about it, right? You get the same answer, but it's a different way of thinking about it. This last one down here is the square root of 4x squared. So this would be the square root of 2 times x times x. If they have a buddy, they can escape. So this would be 2x. So pause the video for a second and try these other 9. Just remind yourself of how you find the square root. Pause the video, try them out. Square root of 81 is 9. Square root of 49 is 7. Square root of 36 is 6. The square root of t to the 8th, well, this would be t to the 8th to the 1/2. Half of 8 is 4. So this would be t to the 4th power. We could do the same thing with this one, d to the 16th to the 1/2 power. So that would be d to the 8th. And then this would be y squared. For our last row here, we have 9t to the 4th, 7d to the 8th, and then 6y squared. So hopefully you found those easy. Hopefully you found that good refresher, good practice. As we take a look at factoring difference of squares. So factoring a difference of squares. First of all, difference. Difference means that we need a subtraction problem, right? Difference is one of the words in math that we use to represent subtraction. So the problem that we look at when we're factoring a difference of squares is subtraction, all right? The other thing we need, as we remind ourselves, is we need to be able to square root each side. We need to be able to square root each side. So we've learned all about multiplying polynomials and finding their product. So this time we've been given the product. We need to figure out where it came from, how we got it. So first thing, do we have a subtraction kind of a problem? Yes. Yes, we do. Next thing, can we square root each side? Well, let's think about what the square root of t squared is. Let's just think about that. Square root of t squared, that'd be like having t times t, or having t squared to the 1/2 like we just practiced. So we should get t. So then let's think about what the square root of 4x squared is. So that would be the square root of 2 times x times x. Or you could do 4x squared to the 1/2 power. It means the same thing, and in the end we get 2x. So when we take a look at factoring this, at figuring out what got multiplied to make t squared minus 4x squared, we're going to put two parentheses, all right, two sets of parentheses, and then we get a t for our first term in each of these, and then we have 2x. So we have a plus and a minus, the very last thing we need to have. So now I'm going to prove to you that this is in fact the answer we want. All right, I'm going to do a quick check with an area model. So we have x plus 2, t plus 2x, and we have t minus 2x. Well, t times t is t squared. T times negative 2x is negative 2tx. T times 2x is 2tx, and then negative 2x times 2x is negative 4x squared. So we have t squared, as I just read off my area model, minus 2tx plus 2tx minus 4x squared. Hey, these are like terms, so we can combine them. Negative 2tx plus 2tx gets us 0, so we are left with t squared minus 4x squared, which is exactly what we started with. So yes, I know that what I get is the correct answer. There are different ways of factoring. We're going to learn about them over the next few lessons. Today we're starting with what, in my opinion, is the easiest and the most fun, which is just difference of squares. So let's take a look at our second example. This one, we have 25m squared plus 16n. Uh-oh, it's an addition, but we know that we need to have a subtraction. So this one, we cannot factor using difference of squares. So we're just going to leave it. We can't factor it. The best we can do is 25m squared plus 16n squared. We're going to learn different ways of factoring, and we might be able to use one of those ways in the coming days, but for now, we can't do it. So let's take a look at our last example on this page, which is 4x minus 9y. So do we have a subtraction problem? Yes, we've got a difference. Perfect. Now we need to see if we can square each side, or square root, as the case might be. So we've got 4x. The square root of 4x is going to be 2, and then something, right? But we can't square root an x. It's not a square. So this problem also cannot be factored. Using difference of squares. So I want to do two more problems together on the next page, all right? And then I'm going to have you guys practice a little bit. So let's turn this page over. The next one we're going to practice is this one right here. So the 49p12, p to the 12th power, minus 9q to the 5th. So let's start by, do we have a square root? Oh, do we have a subtraction sign? Excuse me. Yes, we have a subtraction sign. Next, can we square root? Well, let's think about what the square root of 49p to the 12th is. We should get 7p to the 6th. So then let's think about what the square root of 9q to the 5th is. Well, the square root of 9 we know is 3, but what's the square root of q to the 5th? That doesn't come out as a nice number, does it? Because we end up with q to the 5 halves. So we can't square root q to the 5th. It doesn't come out as a nice number. We can't do it. So this is not factorable using our difference of squares. That's my little symbol for difference of squares. So we would just leave it. 49p to the 12th minus 9q to the 5th. We're just going to leave it. Again, we'll learn different ways. For now, we're just focusing on this one. For our second example here, we've got 9 squared. Well, the square root of 9 squared should be just 9. So let's think about what's the square root of 100x to the 4th. That should be 10x squared. So I give myself two parentheses. The first term in each of them is a 9. And then for one of them, I'm going to do a plus 10x squared, and the other one will be a minus 10x squared. It does not matter which one has the plus and which one has the minus, so you could do a minus here and a plus there. That's fine, it doesn't matter. But one must be an adding, one must be a subtracting. So this is our answer. I can prove it to you with another area model or another distributive property, but I'm going to hope you guys just trust me by now. So try the next 7, all right? We've got this x cubed minus y cubed, and then try all the way through this 81x to the 4th minus 16. Pause the video, try it for yourselves. I'm going to give you the answers in just a second. All right, this one right here, we cannot square root x cubed, so this one is also not factorable. Factorable by the difference of squares. For our next one down here, you should have gotten 2r cubed plus 5s cubed times 2r cubed minus 5s cubed. For this one, we should have an x squared minus 12, x squared plus 12. Again, does not matter if the plus or the minus comes first. It can go either way. For this one, we should have an x minus 5, x plus 5. For this one down here, we should have a 5x squared plus 3y, and then a 5x squared minus 3y. For this one, we should have an x plus y, x minus y. And our last one is a 9x squared minus 4, 9x squared plus 4. All right, let's do another 2 examples together, and then I'm going to have you guys practice the rest on your own. So for our first example, we've got x squared minus 121. It's very handy if you have your squareds memorized, all right? It's very handy. Or I gave you that table back at the beginning of lesson 6.2 where we had all the squareds listed out. So that could be really handy as a reference as well. So if we think about x squared and what the square root of x squared is, we should get x. When we think about the square root of 121, that should be 11 times 11. So the square root of 121 is 11. So our answer is going to be x plus 11, x minus 11. And that's what we get for our answer. Let's check out our next one down here. So we're starting with a subtraction, yes. The square root of 25m squared should be 5m. Then we have to think about the square root of 4m to the 6th. Well, we get 2m cubed. So in our parentheses that we write out, we should have 5m as our first term, and then plus 2m cubed minus 2m cubed. All right, there are 4 more problems on this page, as well as an entire backside. So pause here. I would try at least a few of them. All right, try at least a few of them. See how you're feeling about these. Pause the video, try them out. All right, for this one, we can square root 4t squared. We get 2t, but we cannot easily square root 20. So this one is not factorable by the difference of squares. Again, we'll get to how we can factor it, but we can't factor it this way. Square root of 1 we know is 1, so that's nice. Square root of 9y to the 4th is 3y squared. So that's also nice. So this one we get 1 minus 3y squared times 1 plus 3y squared. This one has a plus sign. We cannot factor. It is not factorable by our difference of squares. Next one, we have r squared minus t, and then r squared plus t. Again, doesn't matter which order it is. All right, let's take a look at the very, very last page. All right, let's take a look at the very, very last page. So you should have 10x plus 9 times 10x minus 9. X squared minus 2 is not factorable. 2 is not a square. So it's not factorable by difference of squares. Same thing with our next one, not factorable by difference of squares. Then we get negative 12 plus x cubed times negative 12 minus x cubed. Then we have a plus sign, not factorable by difference of squares. 10p plus 5q times 10p minus 5q. Then we have f k squared times f minus k squared. Then we have 4b squared plus 11c cubed, 4b squared minus 11c cubed. 7x squared plus 5y cubed, 7x squared minus 5y cubed. 2 plus 4x squared, 2 minus 4x squared. G to the fifth, we cannot factor. It's not a square root, so we cannot do difference of squares on this one. The next one is a plus sign, so it doesn't work again. The next one, we have a negative t squared. I want to remind you that we cannot take the square root of a negative number. Cannot. So it is not factorable by difference of squares. The next one, we have v squared plus 8 times v squared minus 8. Then we have another not factorable. It's 15. That's not a squared. Then we have c plus 5 times c minus 5. Then we have x squared minus 120. 120 is not a square, so we cannot factor it. Then we have 5c plus 4 times 5c minus 4. If you are struggling with any of this, please email me. Ask me questions, all right? The skills practice will be posted. Please ask me questions.